what an audience. I was expecting some 20 people. And to be honest, I'm not a professional speaker. I have a regular job, quite a challenging job at AstraZeneca in Södertälje. So if you see problems with my slides or spelling wrong, etc., that's due to the fact that I don't have the time to spend hours in doing material. But I'm going to take you through the journey, the digital journey. How do we transform AstraZeneca in Södertälje into the digital future? And who is Jerry Johansson? Yeah, I have quite a long background. I started in the automotive industry. You know, in Södertälje, we have two huge companies. One company produces trucks, Scania. So I started my career in producing, had different roles, but actually my career started when I moved to Brazil, 2011. That's why I chose Michel Tello. He was very popular at that time. I lived in Brazil. I was head of maintenance in Sao Paulo for the Brazilian site. But you know, the hard thing to be an expat is not to go abroad. It's to come back to Sweden again. When you go abroad, you are someone. When you come back, you are anyone. So that was what happened to me. So I had a really good job in Sweden. I was responsible for the maintenance in Luleå, Södertälje, and Oskarshamn. 600 people reporting to me, but I didn't felt that I got the attention I expected. So I moved on to AstraZeneca. Since June 2017, I'm working for AstraZeneca in different roles. And actually today I'm responsible for asset management, soft services, FM services, capital products, and OT deliveries in Södertälje. I have roughly 200 people reporting to me, but we also have 700 partners helping us in my delivery. So quite an intense job. Did you know that you can become European champion in maintenance management? You can. Actually, I was certified as a European expert in maintenance management back in the days, 2004. In 2014, I was chosen to be the Swedish maintenance manager of the year. And then as a consequence of that, I was invited to be the Swedish candidate for the European Championship in maintenance management. Awkward, but I became that person. So you're going to see that in the speech. I'm going to start a little bit. I'm going to train Ali and the Snyder team how you choose the right maintenance activity for the component in the system. But for sure, I also want to have discussions. If there are any questions, stop me. I'm quite sure we can handle that and during my time. So if there are any questions, raise your hand or throw the box and we take it. So what I will cover in my presentation is, for sure, I need to take you through a little bit of AstraZeneca and the journey we are doing right now, where we are in the world. I will also go back then to the basics. How do you choose the right maintenance activity? Because I think we can digitalize everything, but we shouldn't digitalize waste. So that's my theory behind that. So how do we choose the right condition-based maintenance method? There are so many sensors. I was on a maintenance fair in Gothenburg yesterday, and everywhere there are sensors. There are sensors. And we can help you. We can do that. But does it make sense? That's the question. So that is what I need to handle. And then I'm going to show you how we actually have taken a step into Aviva Pi, and I'm going to use the data we capture from the sites and make it better. And finally, I'm going to talk a little bit about the smart factory. But first on, this is the footprint, or this was the footprint of AstraZeneca. It's happening a lot. We are growing, buying up, getting new acquisitions every day, every week, feels like. So this is the network where operations work around the globe. And the funny part with this is that the small site in Södertälje is 35% of the total network, both in sales and volume. So what we do up in Södertälje is 35%. So you can imagine if we have 30 sites around the globe and one site has 35%, the rest of the 30 share 60% of the volume. So they are quite small compared to us. What we do in Södertälje is, What we do in Södertälje is that we have an active pharmaceutical factory. We do the ingredients, we do formulation, we do tablets, we do filling, and we do packing. So we have a complete flow, end to end, which is quite unique. This site where I operate is the biggest tablet manufacturing, pharmaceutical factory in the world. We produce 13 billions of tablets every year in Södertälje. And we export to 30 markets, 30 products over 100 markets, which makes our life quite complicated. Imagine when FDA comes to us to make an audit, or Turkey, or Brazil, they all want to fulfill the same thing, but they have a slight different touch on how they adapt the rules and that applies to us. We have roughly 8% of the sales export from Sweden in Södertälje. And combine that with Scania, then you really understand how important Södertälje is as a city in Sweden. Another thing that I think is quite amazing in compared to Scania is that there's 50-50 between women and men in leading positions, which is really good and takes us to a different layer. And it's also something we work very hard with to promote.
Every day, AstraZeneca develops, manufactures, and delivers medicines to millions of people around the world. New technology is transforming our operations so that we can supply personalized and high-quality medicines faster and more efficiently. By digitizing our processes and ensuring we use accurate and reliable data, we are building the foundations for the factory of the future. Now, digital technology is speeding up the pace of change. By visualizing, monitoring, and connecting everything, we have the possibility to optimize our global network and make more intelligent data-driven decisions. We can consistently and efficiently produce goods that are right first time. And with real-time information, we can automate decision-making, clear bottlenecks, and cut down on waste. Connected and intelligent assets give us deep insights into our processes and equipment. Simulation enables us to develop, design, and optimize our processes virtually without disturbing our physical operations. But new technology is just one part of the journey we're on. Our highly skilled and committed workforce will also play an essential role. People are at the heart of our operations, empowered by the digital know-how of today and in the future. With people and technology working as one, we can continue to innovate as we deliver life-changing medicines to patients.
So our purpose is to make sure that there are medicines to our patients around the globe. And we saw that during the pandemic, there was another pharma company that charged $50 per dose of vaccine. AstraZeneca charged 2.5 to make it affordable for everyone around the globe. Our industry is changing rapidly. In the good days, we made a fortune of Nexium and Losec. Today, we see that the turnover time for medicine is much shorter. So we need to really improve our efficiency and our speed in bringing new products to market. Some years ago, 2% of the new molecules came from Asia. Today, 20-25% comes from Asia. So we see a shift in going east. And how will we do that? Yeah, for sure, we need to go for digitalization. We need to make it smarter, even more efficient, using all the tools we can to shorten lead times and also improve the efficiency of our factories. But before we can do that, we need to make sure that we don't digitalize waste. What is the waste in our flows? Do we have waste in our ways of working? That is super important that we take care of. So for my team, now I'm going to go back to where I come from. I'm a maintenance guy, honest. I'm a maintenance, even though I'm responsible for operation technology and capital product and asset management and FM services. I'm a maintenance guy. And I have a vision that there are no breakdowns at AstraZeneca. due to lack of maintenance. And is that possible? Yeah, it is. I fully believe it is possible. Doesn't mean that we're not going to have any breakdowns, because we're going to have breakdowns. But then we have chosen that. So how do you choose the right maintenance activity then? Any ideas? When I talk to my people, my technicians, or the people on the shop floor, I do it quite simple. I just have 3 pictures showing them. So I talk about where you have a failure curve, you can actually detect something very early, or you have a digital failure. It just happens. So a bearing is a typical failure where you have a failure curve. That's why I think we all know that condition-based maintenance or sensoring on a bearing is absolutely perfect. An electrical card or an electrical component is more of a digital failure. It just breaks and you don't know when. You can do some preventive maintenance, but not that much. Adding on to that, temporary failures and regularity in those patterns, we actually get this picture. And based on this, we can actually choose the right maintenance activity. So what do you think we should choose for the one to the left? A temporary failure with a failure curve. Any suggestion? I'm sure you're going to answer inspection and condition monitoring, right? Ale, wasn't that what you thought about? Yeah, perfect. But what shall you choose for that one with a regular failure and a failure curve? What do you choose for that? I hear you say the same. Inspection and monitoring. Right? It's clear. Because you can measure, you can see what's happening. But what's the difference between these two? There's a difference between these two. The first one, you don't know when it's going to break. It can break today, tomorrow, in a week, in a year, in 2 years. The other one, you know it's going to last for at least 3 years. Or if the probability increases after 3.5 years, you can trust it's going to work for 3 years. So depending on these things, you choose a different type of monitoring equipment. I would say for the temporary failure, if it's a critical failure, you have to go for sensoring and connecting to your upper systems. But in other case, maybe it's good enough with a handheld control equipment. But then we have the one to the right. It's a regular failure and it's a digital failure. What do we do then? Does it help with a sensor? No, it doesn't, because you don't know when it's going to, you don't have time to react. Then we have to do exchange of component. And in the old combustion engine, the timing belt, I think, is the best example. The timing belt lasts for 75,000 kilometers over 5 years. And then you have if the timing belt breaks, the consequence is severe and you can't continue your journey. So that's the reason for you do planned exchange. And in the last case, it's actually corrective maintenance. But is corrective maintenance something we would like to have? No, we doesn't. But if we have corrective maintenance and activity, we need to make sure that we have redundancy. If it's a critical system, if a nuclear plant, if the pump stops in the nuclear plant, they have a redundant system. I was once at the airport in Frankfurt, was about to fly to Sweden, to Gothenburg, and we had to change airplane. And I asked the pilot, why? Because one of our hydraulic system doesn't give me this clear signal. I don't have the pressure from one of my hydraulic systems. Okay, you have 2. No, I have 3. So he had 3 hydraulic systems, and he wasn't allowed to take off if one of those weren't giving full pressure. So then you understand how high security they have on that. You can calculate the uptime of such a system. But what's the most common failure with a redundance? Have it happened for you that when you start your redundant system that it breaks down? For me, it has. I can admit that. Because if you have a redundant system, you tend to be a little bit more relaxed. The operation is working, so you don't have the stress. You don't take care. If a redundant system goes down, you need to repair it as quick as possible. Because you can also be assured of that the system that started up hasn't been maintained as it should be. So the bearing maybe has damages and will break down in 1 week. So that's another thing. Then we have spares. We need to have spares because it's all about how fast can we repair it. And here we can see huge digital systems. How can we connect each other with spares? How can we work with that? I don't see that, unfortunately, on the market as I want to. It's not a secret that if we have spares, to borrow spares with each other. We're not competing. We can do that. We try to do that with SSG, which is a Swedish standardization group up in the north. Works so, but okay. And then finally, it's about having the right skill. Because when it breaks down, it's all about time to restore. The time to restore is crucial. Do you agree? Maybe this is not your market, but I'm sure in your companies or wherever you are, you see something of this. For me, it started actually 2003 when I was in Malmö on a course called RCM, Reliability Centered Maintenance. On the train back to Södertälje, I said to my boss at that time, this was really good, but we're never going to do this because it's too time consuming. During my years, I've understood that what we need to do is we need to understand the system. What does the system do? What is the function of the system? And what does the component do in the system? If we understand these things, we can actually apply the right maintenance method. And by that, the right monitoring system. So for us, we do work with, we all want to extend the lifetime of the component. And that's absolutely the best thing we can do from a sustainability perspective as well. If we can prolong the time of the component without replacing it, we're gonna save the environment as well. So super important that we really take this serious. And if we don't do cleaning, inspection, lubrication, and tightening, which are the basics in maintenance that you need to make sure of, it doesn't make sense to go for digital products. I don't need to add sensors if I don't have a proper lubrication system for lubrication. If I don't take care of my bearings, lubricate them as I should, I don't need to put a sensor to measure the vibrations in the bearing to realize I haven't done I haven't fulfilled my preventive maintenance route, which is quite common, to be honest. So these are the basics of maintenance, and that's simple, to be honest. Then we just need to understand how can we take this into the digital future and what can we do with it, because today there are so many more things we can do to actually benefit from this. And we are somewhere coming from the reactive maintenance. We are on time-based maintenance, which means that you send your car to the service every year, or after 15,000 kilometers, you go do the service independent of how you have used your car. That's a written rule. Because our car manufacturers, they make money off service. They don't make money on the car. They make money on the aftermarket, which is clear. But we want to do condition-based maintenance and also in the future do more predictive maintenance. We started 2014 and installed quite an advanced condition-based monitoring system on a machine. the result was a disaster. Why? We chose the wrong asset. So what are the assets you should choose? So that's super important for me. At that time, we didn't understand why we chose a packing line. We had 10 similar parallel packing lines, and we chose one machine and one packing line. What if that machine stops? Is that critical for us? No, because we just replan for the other lines. But what if the freshwater pump in Snäckviken stops? Then the whole site stops. That is a critical asset in that sense. So what we have done is actually we have divided our assets into 3 layers. We call them bronze, silver, and gold. For the bronze, we use quite simple tools. A sensor, maybe $50, $50. It doesn't tell you the full situation of the asset, but it gives you an idea. Do I have fever or not? Yeah, it seems like the temperature is rising. I need to go there with a more advanced system to really understand what's happening. What's the problem with this bearing, or what's the problem with this machine? So this is just an example how we used Intertechna's Blue Vision. Didn't work very well, to be honest, but the principle is that you can actually choose simple sensors. And on the maintenance fair yesterday, I met a guy, he was selling sensors, and he was informed that I'm going to go to Azerbaijan for the oil field there, and I'm going to install sensors. They don't want to measure the vibrations, they just want to know if the pump is running. If the pump is running, there are vibrations, then they know it's working, so then they can make it more efficient. I want to be more precise than that, so I go for silver, I go for one layer, then I say it's vibration monitoring. It can be handheld devices, or it can be with wired sensors. I measure in real time 24/7. Depends on the asset and the criticality, even within silver. So 50% of our critical assets have online measuring today, and we are expanding that dramatically. And it's 2 to 4 points per asset, and since we did this, we have had no breakdowns on critical asset supply in Södertälje. No pumps, no HVACs, that has stopped. And that is nothing you see in the book closing, in your books. You just spend money on something that don't happen, which is the backside of being a maintenance guy. If you do a good job, no one understands what you have done. If you haven't done your job, everyone complains. Also seeing how quick this market changed and what's happening now, how fast it really goes. I would say that 2 years ago, I wanted to have this type of solution where I actually exported my data to a cloud and give the data to a supplier that helps me to analyze and come back. My IT department said, no, you can't do that. I said, why? Because we need to keep the segregated network secure. Yeah, but if I send out data, it's vibration data. Yeah, but it can be hacked. Yeah. What does it mean for us if Pfizer or someone steal our data and they will say, okay, there's a rotating item in Södertälje that has high vibration. They don't know anything about it. It's not critical data. A month ago, I was in a discussion with my IT colleagues regarding the installation, and I said, why don't we do like this? Why don't we set up a cloud-based solution so that you can so that we can get this feedback from the supplier? And I said, 2 years ago, you didn't allow that for me, and now you allow it. This is how fast it goes, and I think it's something we should be aware of. And how do we, with the huge organizations, adapt into that? But we have also actually done something quite fun. We did already in 2019, 2020, we did for some supercritical assets, we did predictive maintenance, machine learning. So we captured all the data we had from SAP, which was maintenance data. We also captured a lot of data that we have in our old historian database, an AspenTech product. We are going into Pi, but we also use that data and we merged it and we trained our agents to find deviations. And what do you think about the result? AI, that's the shit, isn't it? Yeah, some more facts behind the product. 2 to 3 years of data, 10 assets, 600 sensors, 50 trained agents, like temperature, pressure, humidity, etc., etc. So what was the result then? It was very sad, actually. We got the alarm, we saw something's going to happen, but we never understood what. So we saw something is going to happen, but we couldn't find out what it was that's going to happen. 3 hours later, we got the alarm on the HMI telling you need to change this pump because there was something problem with that. And why didn't we understood that? Because the technicians need to be trained, and we need to upskill them. It's a new type of people we need to bring into our factories. And complex technology requires massive training. I don't think we have these type of people in our workshops yet. Maybe we'll have in the future, but we don't have these data analytics in our factories yet. And also, what type of data did we have in our database? And back again, was this the best choice of machine? No, because there were 10 parallel machines, and they did the same thing. In one sense, they were the right machines to choose, but in another sense, not. Because my finding is, my question is actually, will we actually manage to build up the needed competence with the situation on the market, hiring people? It's very hard to hire skilled people that want to work in a factory. So how will we build competence? But also, do we understand the machine? We haven't designed the machine. It's very easy to sell a ball screw when I was in the automotive industry, there was a guy in Västerås, and he promised me, I can sell you ball screws. They are super cheap, half the price of the original one, and they fit as good as yours, and I will deliver them in 5 hours. For a purchaser, that's absolutely music. Half the price, no stock, delivery when we need it. So what did we do? We purchased from him, and we started to get problems. Why? Because they were too weak. They weren't designed for the machine we had, but they were cheap. So do we understand how the machine as it was designed? I think we need to understand that. And then we need to ask ourselves, does it make sense? Do we really benefit from this? I personally don't think we should go for these advanced models if we have an overall equipment efficiency below 70%. Then we have other losses that we can work with in this case. Do we get enough with data? I have 5 machines. Novo Nordisk maybe have 5. Then there are Pfizer that have 10. But I only have 5. Do I get enough data so that I can take my decision based on facts? I don't know. So my question is, when will Schneider and others adapt and start to sell updated, improved design based on our experience? I can freely give my data on the circuit breakers or a ball screw to the supplier on the machine if they come back with a better design. And that is, for me, the double loop learning. So instead of going back internally, updating our maintenance plans or ways of repairing the things, we should go back and actually update the design. And I have a really good example back in the days when Fanuc, I don't know if I can talk about Fanuc here because they're competing with Schneider in some sense maybe, but they called me and said, hey Jerry, you have a component in your machine that we have seen has a higher failure rate than normal. We would like to replace them for you, free of charge on Saturday. Is that okay for you? Perfect. Machine standing still on Saturday, you're welcome. They came in and did it. ABB had the same problem with their main computer in the robots. One broke down. Okay, one can break down. 2 can't. So I called them and said, what's happening? Yeah, we know we have a problem with those main computers, but we replace them for free. I don't want you to replace them for free. I want you to replace them now when I'm standing still. And maybe the best thing of this is Scania. They actually have a flexible maintenance plan based on the usage of the fleet. And I think that is the point is, they have millions of trucks connected. They capture the data on the trucks, they store the data, they have designed the truck, they have done the service on the truck. So if you have a truck going here in Malmö delivering packages, you have one maintenance plan. Compared to the truck you have up in the north going in the mine, that's a total different package. And what does that give us? That gives us that use our assets in a better way, lower cost, and for those guys up in the north, the right maintenance based on their needs. How many of our car manufacturers does have this? I was fooled by Kia. I'm never going to buy a Kia due to this, but this is something. I think we need to have the full control of this. So my landscape looked like this today, and how am I going to tackle this landscape? There's a lot of data in different islands. We haven't connected it very well. So what I think we need to do is to find a way how we actually can start to organize the data flows, get the data into a certain, so that we actually can visualize, make reports, analyze, notify and share with operators and the technicians. And for me, using a Viva Pi, the Pi database as a data historian, which our purpose is to be able to show for the government in 5 years' time that in 14th of March, the temperature in building 616 was 20 degrees. Humidity was according to standard. That's the purpose we have for this. But what we see is that if we start to connect our assets and our smart sensors, capture the data from our smart sensors. In June this year, I'm going to have on a building level, I'm going to have all my buildings connected from energy, water, steam, heat perspective connected to Pi, so that I can really start to elaborate, set the context of the data, analyze the data, and present reports. This year I spent 6 months to find a leaking pipe. In the future, I hope I can find it in just some hours, some minutes, or I even can get the alert. Now you see we have an abnormal flow in building 616. Please go there and check it. So this is what we're going to do. And how did we came up to our business cases? Yeah, we worked with. We had some strategic meeting together where we sat down and really looked into why should we do this, what shall we do. Now we have our plans, so we are going to going into how will we do this, and so then we're going to build it. And very simple. I was going to show you 5 cases. I don't know if the numbers are right. I doubt, but actually by just monitoring energy. Water leakages, we can save quite a lot of money. And we also will improve our scoring in our sustainability reports. So I hope a lot on this, that we will do this with the data from Pi and with algorithms, that we will improve our flow. And by that we will have dashboards. This is a BI dashboard we have for energy measuring. It's not complete, but I want to make this useful for the person owning that factory or that building. I want them to be responsible for the energy consumption, not something that I report every month, which is totally understandable. I want you to understand this is your building and you have consumed this. And if you have this, you can also easily go in a weekend and shut down everything that you don't need to have up and running. And that's your base load. And that's your target. That is what you should aim for every weekend. Shut down all the machines that you can shut down all the lightnings, shut down all the ventilation, all heating that you can shut down, and that's your baseline, and then you should compare to that. Another problem you have is also the maintenance software. We have an old SAP. I was amazed on a maintenance fair yesterday. Was to see all the things they really develop. But we actually also did a very simple dashboard based on BI to make sure that we can visualize and tell our people, our operators, our technicians, what's the backlog, what's you have to do, what's the workload for you this week. If I go back, zoom out one step, we talk about AstraZeneca and end-to-end flow. We talk a lot about advanced process control. The latest, I don't know if there's someone from pharma here, but continuous direct compression, where you actually blend your substances, press the tablet, coat the tablet in one step, and release at the same time, because you know the flows of the different parameters in real time. That demands a lot of data handling and process validation, but also working with optimization, like digital twins, and to have better insights in the factory. Where do we have the material standing, etc., etc. Augmented reality. For trainings, we can train a lot. We have a lot of rooms where you need to be qualified and certified before you can enter. How can we train those movements you need to do? How can we present this for our people, smart workforce? How can we make all the data we have accessible in an easy way so that you really can understand what you see? Intelligent asset management is all about sensoring. How do we measure the flows, energy, media, etc., etc. And for sure, working with robots and physical automation, like cobots, etc., where it's possible. And in the final end, what we are really aiming for is to have affect our sustainability. AstraZeneca has a target to be carbon negative by 2025 in scope 1 and 2. We have signed up to the Paris Agreement, and this is really a push from our leader to be there. So through the chain development, we use continuous API, we work with different toolings to get it out, yield optimization, process optimization, factory dashboards, etc. But this is no business for you. So my conclusion then is that high uptime is based on a component in the system. If you want to have high uptime in your factories, you need to understand the component in the system. With the right maintenance program, you will get good results. I'm super sure. I have seen the change. Digital tool demands OEE higher than 70% before it makes sense. That's a question mark. I don't know, but I think so. I think there are other things. If we are below 70% in OEE in our factories, there's other things we need to work with that are easier and cheaper. And make sure you don't digitalize waste. And finally, I think this is all about people. 10% technology, 90% people. If we're going to do this change, it's about us. It's about the people. How do we involve the people in the shop floor? How do we get them on board? Do we have any questions? The silence is powerful.
You scared them.
I don't think so.
Great learning. Any questions for Jerry? I'm sure there are. Here we go.
Oop.
Perfect, thanks. What was the biggest challenge for you when you were transforming this into AstraZeneca?
The hardest thing was actually to I think to get the people understand, to really level up as I have been into maintenance and I'm raised in maintenance, we worked a lot with the basic understandings of maintenance, and that has been a great success. Then it's always about how do you motivate? It has a cost. What's the benefit? Can you show the benefit? No, but you can ensure a higher uptime. We have a case, we prevented a failure in a sterile manufacturing factory. 1 hour in that factory is $20,000-$30,000 in cost, and it takes 24 hours, so it's quite a lot of money. And then, so how do you make this? I think one of the problems we have with talking with our finance people is they don't understand technology. They understand numbers. So how do we transform these into numbers? I have never had a problem to get investments through if I convert it to numbers. The best investment I have done is when I at AstraZeneca we had a breakdown after thunderstorms. There's a small glitch on the grid on the net. We lost the FMS, so we lost the control of the numbers. We couldn't prove that the factory was sterile, so we had to re-clean it. That took 20 to 24 hours every time. I installed a small UPS for 5 million Swedish crowns to make sure that the UPS took over the critical loads the first 30 seconds before the DC genset started up and gave power. And that investment was paid in 4 days. So I started on Monday, on Thursday I had a thunderstorm, and they didn't realize it was a thunderstorm. Then that investment paid, and now they don't remember it any longer. So to do that, I talked numbers. I talked what's the consequence, what's the cost, what's the alternative cost for that. So I think that is something. Otherwise, I think people do like this.
Thanks.
Great, thanks for the question. Anybody else? I have a question.
Yep.
I think it's a great example also, and thanks for sharing. It was really a learning session. A great example for having use cases, starting with the maintenance that you described, but also now evolving into looking at the energy consumption, look at the water consumption, things like that. So all based on data. So you identify different use cases as you move along. But where do you see the future if you look 3 to 5 years ahead? And not only with the site in Södertälje perhaps, but all the other sites. How do you work with that methodology in AstraZeneca in general?
And that's a really good question, because that's super complex question. We don't tend to talk to each other. Invented here, I think we have heard it all. If it's not invented by us, it doesn't make sense. When I was in Brazil, the Brazilian guy says, I go to Sweden every year, say some good thing, I go back and implement it. Swedes never go to Brazil and see what they have done there. They want to invent it by themselves. They are suspicious. So I really hope, I do expect a double loop learning. I want my suppliers to really connect their machines, to really understand that if they can improve the uptime of the machines or the performance of their machines, we're going to continue to purchase from them in that sense. And I think they can help us. I don't think we will be able, maybe in 5 years, we have connected in a common data structure. It's hard to say. I hope we are, but I'm not sure.
Great, thank you. Final? Nobody? Jerry, thank you so much for a learning session. Thank you for investing time with us. Thank you so much.
Tack.
Some local chocolate for you.
Tack.
Thank you.